Hello everyone, this is Levi Sheridan, and today I am making a video about my 3D printed Planetary gearbox. I designed this gearbox in Fusion 360 and printed it in PLA on my Prusa Mini 3D printer. The gearbox works well. The sun gear input is here. The sun gear has 9 teeth. There are 3 planet gears that have 12 teeth each, and there's 1 ring gear that has 33 teeth. As you can see, when I rotate the Planetary gearbox input, the planet carrier shaft rotates at a slower speed. The ratio is 12 to 9 as the planet gears have 12 teeth and the sun has 9 teeth. I'll hook it up to a drill so it can spin a little faster. The drill also has a little bit of yellow tape, so you can see how the rate of rotation is definitely lower on the output of the Planetary gearbox. The whole gearbox is held together with these 3 screws that I will take off so you all can see inside of it. These 2 halves, the 2 case halves, hold everything together, and the through holes are both tapped, so it's held together really well with these M5 10mm screws. Once I take off the 3 screws, you will be able to see inside of the gearbox. You'll see the planet carrier, you'll see the sun gear, the planet gears, the ring gear, as well as all of the bearings that I've included in order to help this gearbox run smoothly and to increase the strength a little bit. So this is the 3rd screw, and now that that's off, I can separate these 2 halves. This half is the simplest half. It just has 1 bearing in it, and it basically it restricts the planet gears from moving off of the ring gear. Basically, this is the planet carrier. This is the sun gear shaft that you'll see the sun gear in a second when I take the planet carrier apart. This is the ring gear. You can see how the planet gears just sit on the little ledge and how this surface retains the teeth of the gear. Now that the halves are separated, I can push on the planet carrier output shaft and separate the planet carrier from the ring gear. These are the 2 halves that hold everything together. There's 2 bearings, 1 on each half. And now that I have the planet carrier and sun gear assembly taken apart, you can see how when I rotate the sun gear input, the planet gears rotate. And that's a very smooth motion. These 2 halves are held together only by friction. Apart from when it's in this assembly, it's held together with friction. When these 2 halves are together, it's sandwiching the whole thing together, keeping it assembled. But in this state, you can just pull the 2 halves apart and they separate like so. And basically each sun gear has its own bearing, and those bearings sit on these pegs here. You can see how there's a peg on each half of the planet carrier. I can also slide out the sun gear here, and there's a bearing in each half of the planet carrier that supports the shaft of the sun gear. So you can see how that part sits in there, and then this part goes through here. And these 2 halves can't be held together alone. They need to have the bearings together because the pegs have a snap fit. So when I attach it, the planet gears, they snap on and they hold on really well. They spin well. And then when I put the other half on, it will snap the whole thing together like so. And then this whole assembly is very strong and rigid, even though it's just held together with friction. And then when I put the 2 case halves back together, it's held together pretty permanently. The whole thing works really well. I'm really happy with it. I made this in preparation for a Planetary gearbox I would like to cast. This is kind of a prototype, and I'm going to take this design and modify it so that I can have success in casting it. But in general, this works really well. This was all 3D printed in PLA, designed in Fusion 360. This is Levi Sheridan. I hope you learned something and found this interesting. Thank you for watching. Have a nice day.